Good morning, dear students. Today we are going to learn about ribosome. Who first discovered this ribosome? It is George Palladay. So that name sounds like that one of our evening snacks. Palladay is so common in India. Anyway, I just simply refer about that to easily memorize the name of the scientist who first discovered the ribosome. The Palladay is just for joking. Leave that. George Palladay is the scientist who first discovered the ribosome in 1953. And while he discovered the ribosome for the first time, the detailed structure and mechanism of ribosome's function it is elucidated by Venkataraman Ramakrishnan et al. So that also is very important to mention. So that's why we need to note that name too. It is present. Ribosome is present in both prokaryote and eukaryote. It is present unanimously in both prokaryote and eukaryote. And in the case of prokaryote, as there is no membrane-bound nucleus, it is possible to see only freely in the cytoplasm. The cytoplasm it can see freely. And in the case of eukaryotes, it occurs free in cytoplasm. And also, we have already learned that it is seen attached with the membrane of endoplasmic reticulum. So, in these two places, we can note ribosome in the case of eukaryotes. And while considering chloroplasts and mitochondria, in their matrix too, we can find the ribosomes. Then regarding the number, in prokaryotes its number is a few thousand, in the case of much more, several millions. And as we consider the case, examine a mammalian culture cell, inside that cell scientists could number around 10 million ribosomes per cell. Then different types of ribosome. Before that, we should know about its shape. It is almost spherical particles with a diameter 23 nanometer, and it's composed of a small subunit and a large subunit. And its measurement is measured in Swedberg unit. It is represented by S, and S is the sedimentation coefficient. Then what do you mean by sedimentation coefficient? Sedimentation coefficient is simply it is the sedimentation rate of speed of sedimentation of a substance particle in a medium as it undergoes centrifugation. As it undergoes centrifugation, at what rate it is sedimenting, it is settling, that rate is sedimentation coefficient. And from that itself we could understand that heavy particles, as it have high density, it will move fastly, it will sediment too fast, so they will have high sedimentation coefficient. So let's keep that in your mind, leave that. Anyway, understand only this much. Sedimentation coefficient, S is sedimentation coefficient. So ribosome is measured in Swedberg unit, that is S, and it is a sedimentation coefficient, leave that. Then different types of ribosome, that we are coming to the point. Mainly two types, prokaryotic and eukaryotic. And also we need to mention about mitochondrial and chloroplast ribosomes. Prokaryotic ribosome, they are smaller than eukaryotic ribosome, and its sedimentation coefficient 70s, and its subunits are 30s and 50s, small subunit, large subunit. Then considering about the eukaryotic ribosome, sedimentation coefficient is 80s as it is an assembled form. And separately considering the two subunit, each subunit are 40s and 60s, means one subunit, a large subunit with a 60s sedimentation coefficient and a small subunit with a sedimentation coefficient of 40. Then mitochondrial and chloroplast ribosome, these ribosomes are smaller than the cytoplasmic ribosomes. Cytoplasmic ribosomes means the eukaryotic ribosomes, and that's seen in the cytoplasm. Why they are smaller than the cytoplasmic ribosome? Because it is considered, it is believed that this mitochondria and chloroplasts are actually prokaryotic cells engulfed by the eukaryotes in the past time of evolution. So that is why they have more similarity with the prokaryotic ribosome. That is why they are smaller. And it is more comparable to prokaryotic ribosome. Why? Because it is believed to be descended from prokaryotes in early history of evolution. And while considering the ribosome's composition, in the case of higher organism, they possess equal amount of RNA and protein in the case of higher organism. While the case of prokaryotes, which is more RNA's amount is more than proteins in the case of prokaryotic ribosome. RNA is more. Okay, then we are moving to the structure. The ribosomes process the translation domain where translation is happening. So that's the important region in the ribosome responsible in a translation process. And for that domain, both the small subunit and the large subunit is contributing. Both are contributing to form that translation domain. The upper portion of both subunit contribute to form that translation domain. And in that translation domain, we can see a middle protuberance. In that middle protuberance itself attaching all the important enzymes involved in the translation process in this middle protuberance. So next we are going to see another important feature of ribosome, that is about its binding site. They are the place where different steps of translation is happening. So let's see which are the binding sites. A site, it is otherwise called the aminoacyl site. What do you mean by this A site or aminoacyl site? It is the point where that aminoacyl tRNA enters the ribosome. So like when it is compared with our house, where is the hall? To the hall itself, whenever a guest arrives our house, they are first coming to the hall portion of our house. So like that way, A site is the hall of the ribosome where all tRNAs, that is carrying amino acid, is arriving, coming and attaching. So that is the A site. Then we are going to see that in this picture. This is the A site. And in that site we can see here, this is the tRNA carrying the amino acid. Next is P site. P site is this one. What we can see here, a chain of amino acids called polypeptide chain we can see. So polypeptide chain carrying tRNA is positioned in this P site. So P site hold the tRNA carrying the polypeptide chain. So we have seen that here arrived another one tRNA carrying an amino acid, and this amino acid also need to be added to this polypeptide chain to increase its length, to complete its translation. So here actually present a hydrogen bond, a bond between the tRNA and the polypeptide chain. By breaking this hydrogen bond, this polypeptide chain moves to this tRNA and form a peptide bond between these amino acids. And after this, we know that this ribosome need to read the next 3 codon. For reading that, it need to move more downstream. As it moves downstream, this tRNA carrying the polypeptide chain again will come to the P site. So that is its actual position. And this tRNA moves to this position, and this one will exit from this ribosome. So this is happening. So what about that third site? Third site is exit site. That is this one. This exit site means it keep the tRNA devoid of any amino acid, and those tRNA that is reaching here can exit the ribosome to pick another amino acid to repeat the cycle. So that is the E site. These are the 3 sites: A site, P site, E site. E site, once more I am reading. After the amino acid is transferred to the growing polypeptide chain, the new uncharged tRNA moves to the E site and later it will exit. And from here the tRNA exits the ribosome to be recharged with another amino acid. Okay. Next we are going to see the significant factors that is helping to organize the ribosome. Means helping the ribosome to exist in assembled form like a small subunit and the large subunit. For that assemblance requires the magnesium ions. So a particular level, optimum level of magnesium is necessary to keep the two subunits together, and whenever the magnesium level lowers, then the two subunits move apart. They will not stay together. Next we are going to see the composition of prokaryotic ribosome composition. So we are taking the case of the last subunit of prokaryotic ribosome. It is 50S. Inside the ribosome, we just heard that it is composed of RNAs and protein. First, we are going to understand about which are the RNA present in each subunit. In the large subunit, one RNA is 23S, and the RNA that's seen inside the ribosomes are called rRNA. So this is 23S and its weight is 1 million Dalton, and it is composed of how many nucleotides? 3000 nucleotides. And along with that, another rRNA also present, that is 5S, and its weight is 4000 Dalton and is composed of 120 nucleotides. Then another subunit is 30S subunit, and is composed of 16S rRNA, and its weight is 0.55 Dalton, and how many nucleotides? 1540 nucleotides. Then regarding the protein, totally in both subunit, how many proteins are present? 54 different types of proteins are present. In the large subunit, 34 are present, and the small subunit, 21 proteins are present. And as we add these two, it will not form 54. Instead, it is actually 55. Then why? It is telling that only 54 different proteins are present altogether in these two subunits. That's why the reason is that one protein among this 54, one protein is common to this big subunit and a small subunit. So that is why we are counting it as one, as it is common. So that is why as together only 54 different proteins are present in both subunits. Then regarding the composition of eukaryotic ribosome, here it is larger than prokaryotes. Two types are present, those that are found free in the cytoplasm as well as those found attached with the endoplasmic reticulum. Subunits 40S and 60S, and its sedimentation coefficient as it is in assembled form is 80S. And can take the case of 60S, which are the different types of rRNA. Here 3 rRNAs are present, 28S, 5.8S, and 5S rRNA are present in the large subunit. And in the case of small subunit, here present only one rRNA, it is 18S rRNA. And regarding the protein composition, in the large subunit, 50 different proteins are present. In the small subunit, 30 different proteins are present. And as we mentioned about prokaryote and eukaryote ribosomes composition, what about the composition of the ribosome that present in chloroplast and mitochondria? These ribosomes have resemblance, as it is similar when compared with the prokaryote. The composition wise also they are similar with that of the prokaryotic ribosome. So no need to mention about its composition again here. Then polyribosome. What is polyribosome? First we need to see its definition. Its structure consists of multiple ribosomes simultaneously attached to a single strand of messenger RNA actively engaged in translating one mRNA into a protein. Do you understand anything? So that's what I'm going to picturize it. Consider this is mRNA, and attached with this you can see a series of ribosome doing the translation simultaneously at the same time. as these number of ribosomes are doing the translation of single mRNA all together, we can see a structure of ribosome. That structure is polyribosome. Okay, so this mRNA get translated 3 rounds here. As we look to this picture, it is translating 3 rounds of translation is happening here. So what is the significance that we will see in this same slide itself? Each ribosome is attached with the free end of the mRNA when means the preceding ribosome as it moves approximately 80 nucleotides. That number can vary. Anyway, after the first ribosome, as it move ahead, as it translate 80 nucleotide, then the second ribosome come and bind. As it also moves ahead translating 80 nucleotide, then the other one. So the gap will be 80 nucleotide approximately. So what is the purpose of this assemblance of so many ribosomes to one mRNA? That itself means that mRNA is highly demanded mRNA. The proteins out of that mRNA is highly demanded, highly required by the cell. So many rounds of translation is required. So to increase the frequency of its translation, so many ribosomes are assembling and doing so many rounds of its translation. Then moving to the functions of ribosome. First main function, it is doing protein synthesis through translation, and the second one, inside the ribosome, we have seen so many RNAs, and some RNA seen inside the ribosome have enzymatic activity, that is peptidyl transferase activity here. Peptidyl transferase activity means we have seen that between the amino acid need to form a bond, that is a peptide bond. So that bond is formed with the help of these RNA that having peptidyl transferase capability. So those RNA that having enzymatic activity are called a ribosome. So ribosome is present in ribosome. So that also can consider another function of the ribosome. So with this I am going to wind up the section regarding ribosome. I hope every points are clear to you. Thank you. I'm an icon, man. I'm a girl about a 10. I should fuck her in a Benz.